Like, seriously?
Okay, I think if I do that, well, yeah, see, it's a little weird. All right, you ready? Gotta check out the cartoon first. First class thriller right there. Okay. What reagents below? Which one is the best choice for that reaction? Everybody made a guess? Guess is better than nothing. Okay. See how we did. Okay, nobody picked A. All right, I'm going to take that as a good sign. Okay, what do you get when you add hydrogen and platinum to a triple bond? You don't know. An alkane. He's out. Okay, what happens when you add hydrogen and Lindlar's catalyst? Cis double bond. Okay, what is Li and NH3? Yes, that is the dissolving metal reduction. Okay, you can do it with lithium or sodium in liquid ammonia. What does E do? To this compound, nothing. Okay, what do we use E for? Yeah, removing this proton is what we use E for, to make carbon-based nucleophiles. Okay. All right, so we're going to oxidize alkynes using potassium permanganate, remember, the purple stuff, and water under neutral conditions. The product is a diketone. Okay, first what happens, just like when you did a double bond and used KMNO4, you made the diol. We're just going to do it 2 times. Only now you'll end up losing water off of it and you get a diketone. Just kind of unusual, something we don't see very much. So what would you get from this pent-2-ine or 2-pentyne down there? What would you get? Each carbon of the triple bond becomes a what? C double bond O, a ketone. Okay? They got that in 90% yield, y'all. They didn't fool around, did they? They probably also did it more than once, just to get that number.
Can you go back?
Can I go back for 5 seconds? What do you need? What? All you have to do is draw the products, right? Don't you have all the other parts? Don't you have the beginning?
Yeah.
Yeah, that's the point.
Right. Slow.
You're just writing slow on Friday. Okay, we're going to make each of these compounds from the indicated starting material. Show the structures of the organic products after each step. You may use any necessary organic or inorganic reagents. So we're going to spend a little time today doing some synthesis problems because you will have synthesis problems. Okay, so don't think they're going to go away. The more you practice, the better you get. And the more you practice, you get like a handle on it. You can see where to go. Okay, but it takes practice. All right, so we're going to make this 5, 6 from that. Okay, so I'm going to add another slide and then draw that up there. CH3, CH. From that. Did I write down right? I did it from memory, so my memory is as bad as yours. Now worse. Okay? All right, and that is too thick writing. Let's make it skinnier. Okay, so the first thing is when it says to make that compound from that compound, where are you starting? Which compound are you going to start with? The bottom one. Don't take that one and try to make that one. Okay, because I see it all the time. I just like pull my hair out. We can't even do that. We didn't even do that. Okay? So make sure you do what it is. Just like if it asks you for the structure of the alkene from which those compounds were formed, that you draw an alkene. Be logical. We're getting some sleep the night before. Okay. Hey, I've done all those mistakes too. All right, so we're going to start with this compound. I don't know why, but I'm turning it around. Okay, so what is the difference between where we're starting and where we want to end up? What's the difference? How many carbons? 2. So we got to add 2 carbons, right? Do y'all agree with that? Okay. How are we going to add 2 carbons? You have any idea? What? Yeah, okay, so how do we do that? I guess I'll change colors. Let's go. Y'all will miss purple after I'm gone. All right, so what do you want to do? Add a base. Which base? That's important because you can't just add any base. NaNH2, okay? And what is NaNH2 gonna do? It's gonna pull off the acetylenic hydrogen. Okay, that proton's gonna go. And what is our carbon-based nucleophile gonna look like? It's gonna be CH3, CH2, C triple bond C, Na. Okay, and remember it's minus plus. You don't have to draw the minus plus. You can just write CNA. Certified nurse anesthetist. Okay, but you need to realize that that carbon is negative, has high electron density. It's the carbon-based nucleophile. Okay, now what do you want to add to that? What bromide? Ethyl bromide. So we're going to add CH3, CH2, Br. Does it have to be the bromide? No, y'all can pick what you want. Okay? Chlorine, bromine, or iodine will work. Okay, so what happens? What do we get? The ethyl added to which carbon? The one that was negative. So we're going to get okay, so do you see how we work to get our 6 carbons? Okay, now another thing to notice is that I drew the organic product after each step. You'll notice in your homework that they like to do this. 1 and 2 and put them on the same arrow, that's okay. All right. But most of the time I've learned that y'all like to just draw that down because it helps you figure out the next thing. Okay. What did I not draw? I did not draw the little arrows for the mechanism. Okay. You can do that if you want, but I'm not going to grade it. It is not part of the question. I want the synthesis scheme. Okay. And some people may like to do, especially like on this one, they may like to do this because it just helps them figure out which carbon is connected to which carbon. And that's okay. But if you do it and you do it wrong, I'm not going to correct it. I'm just going to ignore it and look at the part I'm grading. Okay. So just FYI. All right. I also didn't draw, removing the proton. If the question asks for the mechanism, then you're going to draw all the arrows. Okay, so you see the difference. This is a synthetic scheme. You're going to show the organic products after each step. Okay, and you get to practice a little bit of that on the online homework. And then there's more in the textbook that will also help you get better at it. Okay, because we're going to be doing this all semester. This is going to be a section on the test on every test. Okay, is going to be doing these kind of problems. All right, now what's the difference between that and that? The triple bond is it there? It's gone, right? And what else? There's an oxygen. Is that the only thing that was there? And 2 hydrogens. What's an oxygen and 2 hydrogens? Water. Okay, so how am I going to put water on there? Okay. And that HgSO4, the mercury. Okay, so all that's going to be used on your arrow. Okay, and you could draw it out long. It doesn't matter really what's on the top and what's on the bottom to some extent. Sometimes we'll put conditions on the bottom, but it's no, if you put all 3 of those things on the bottom, it would have been just fine. Okay, you just need to get them all up there. Okay, so what do you get when you do that? Here's your clue. What do I get? What happens when I add water across a triple bond? What do I get? What do I get first? Put it that way. An enol. You can draw these as sticks too. Okay, and that tautomerizes to that. Okay, you didn't have to draw that, but I wanted you to remember it, so that's why. Okay, see how you think about it. Okay, look at what's different. Think about how can I make it match? What do I got to do to it? You have to have a handle on the reactions. The only way you get that is to practice it. Okay. All right, so now what else was the next one? Okay, so we're going to make this 1, 2, 3, 4, 5 from that acetylene. Okay, 2 bromopentane from acetylene. All right, so we're going to make 1, 2, 3, 4, 5. From that. Okay, so again, what's different? How many carbons does acetylene have? 2. How many do I need? 5. What do you want to do? Got any ideas? Here is your clue. What you want to do?
We started the same way last time.
Sure. Okay, NaNH2. Okay, and what do you get? What are we gonna get? Yeah, so it's what are we gonna write? HC, triple bond, Na plus. Okay, fine. All right, now what do you want to do? Okay. Hmm?
Instead of bromide.
Okay. 1, 2, 3, Br. Okay, so what do you have now? Your nucleophile attacks which carbon? The one that's attached to the bromine, and the bromide leaves. Okay, it's a little SN2 reaction. What do we get now? What goes up here? Your little propyl, right? Or your big propyl, I don't know. That's how big you draw, I guess. Okay, notice we're not worrying about the byproducts. All we're worrying about is what happens to the organic compound. We're not balancing each step. Okay, you'd only worry about that if you were actually going into the lab and you're going to do it once you figured it out. This is the figuring it out. All right, now what's different between that and that? The triple bond is gone. Good. What else? What? A bromine. Is that it? Just a bromine? There's how many hydrogens? 2? 3 hydrogens in a bromine. Do you know a reaction that will put on 3 hydrogens in a bromine in one fell swoop? No, it won't do that. You have to do it in 2 steps. Okay, so what do you want to do first? What? Hydro who? Hmm? Oh, you want to add HBr. Is that what you're talking about? Hydrobromination? Is that what you're trying to say? You didn't say it?
Somebody else was saying it.
Oh, okay. I don't know. I just heard it out there. All right, so what are you thinking? What do you want to add? What do you think? What do you want to do? Add what? You gotta add something. We're gonna be here for a long time.
So you said you have to do it in 2 steps?
Mm-hmm. Yeah, there is no reaction that will add H4Br. Okay, there is no, or H3Br. You're short 3 hydrogens. 3 hydrogens and 1 bromine. That's the difference. Okay, so what can we add? No. How many carbons do I have? How many do I need? These 2 carbons here are which 2 carbons in the product, you think?
The one with the bromine on it.
And?
The next one.
Yes. Okay, that help? So what are we going to do?
So then you're going to add.
Uh-huh. What else we got to add? Yeah, we don't add water because that would add an OH. Okay, we don't want an OH.
Hydrogenation.
Okay, so what do you want to do?
You do it.
And what? And who? Okay. What would happen if you did that?
All add, actual and add for hydrogen.
Go to the outside.
Yes. Dang. We thought we had it. Okay, so how can we fix it so it won't go to the alkane?
Something.
What? Lindlar. What does Lindlar do?
Alkene.
Uh-huh. And what kind of alkene? The what? The cis one. Does that matter on this problem? No, but it stops at the alkene. That's the part that matters. Okay, now what do we do? What's the difference now between that and that? We put on 2 hydrogens. So we needed 3 hydrogens and a bromine. Now we need 1 hydrogen and 1 bromine. Okay, so to go from here to here, what kind of addition is it? Markovnikov. So what's our reagent? Just HBr. If you used HBr in peroxides, it would add the other way. Okay? So you got to keep all that straight. This is where you got to practice.
So in the alkenes, every time we use the bromine, we got anti. Or is that not? Or is it just with peroxides?
You only get peroxides with anti-Markovnikov. With HBr and peroxides, it gives you anti-Markovnikov addition of HBr. That's the only way. Boron does the other, but that is water. You're adding water, you're not adding water.
It adds.
But it adds anti, AD. Yes. Those are your 2 ways to do anti, I think. Those are the only ones. Okay. Let's make that from acetylene. Okay, I changed it because we didn't do the carbines, that uses a carbine. Okay, so I changed it. Okay, so it's I feel like you can hardly see it. Okay, now you're going to need to know what acetylene is. Okay, what's acetylene? Yeah. Okay. You got to know that. Yeah. Okay. All right, so how are we going to make that from acetylene? How are we going to do this one? Ooh, look what I did. I did the wrong thing. Okay, it's 1, 2, 3, 4, 5, 6. Okay, so we're going to make 1, 2, 3, 4, 5, 6. Because the directions may say things like, you can use acetylene and any or other organic reagents that you, but you have to start with acetylene. So you need to know what it is. It's pretty basic. I think it's not a hard one to learn. All right, so let me ask you the differences. What's the differences? Acetylene is how many carbons? 2. How many does that other thing have? How many? 6. Okay, so I got to add how many carbons? 4. Okay, what else is different? I have a double bond, and over here I have a triple bond. Let me ask you this. Those two carbons in acetylene, where are those two carbons in the product, you think? Where are they? Yes. Does that make sense? That's where those two carbons are. Because that makes a difference with how you build chain, right? Right? Last time they were on the end. This time they're in the middle. Okay? So how are we going to start? Here we go. Here's what we're starting with. Acetylene. What are we going to add? NaNH2. Okay, that's going to give us sodium acetylide. Okay, then what do you want to add? Pick something. What are we going to add? Bromine? Methyl bromide. Okay. Okay, so our nucleophile is going to go to the carbon, and what leaves? Bromine. So what does that give us? HC triple bond C, and then what? CH3. All right. So what piece up there have I made at this point, you think? I've made this piece, right? CH3, C, triple bond C. Okay, so I need to add that piece. So how am I going to do that? More base. Okay, NaNH2 is going to give us our carbon nucleophile on the other side. Okay, and then what are we going to add now? Are you following? Propyl bromide. We did that in another problem. 1, 2, 3. Okay, so now what do we get? Okay, where is this going to make a bond to which carbon? From here to this one. Okay, so just in case you have other things on there. Okay, don't just stick it there. It's where the bromine was. Okay, so we're going to go CH3, CH2, CH2, and this is now bonded to the carbon. And then what do we have? Our triple bond. No, we don't have a double bond yet. And then we have a CH3. Okay, so now we got our carbons all lined up. What's the difference between this compound and where we're going? A double bond, and it's what kind of double bond? Trans. Okay, so how do we do that? NaNH2? No, Na in liquid ammonia. That's important because that's where the hydrogens are coming from, is that ammonia. Okay, and so that will give you, you've got to practice this on the homework some. And at some points, it may say to make sure your double bond geometry is clear. Okay, so make sure you draw it out like this in order to get it. I kind of am out of room, y'all. Okay, I got too far to the left. Okay. What if you wanted a cis double bond? What would that reagent be? H2 and Lindlar. Okay. What if you wanted it to be an alkane? H2 and a regular metal. Okay, would go all the way. Okay. A lot of times what we do is we think about the problem backwards. That's called retrosynthetic analysis. Retro, going back. Okay, back in time, back in the molecule. We're being a little retro. Okay, so we're gonna make this from this, and we're gonna go backwards this time, okay? Usually what I think most people do is they do a little forward and a little backward, and they go, okay, I got it. And they meet in the middle, kind of, and they figure out where the molecule's going, okay? So we wanna make this from this, okay? So remember, always analyze. What's the difference? What do we need to add? We need an OH. What else? One OH and hydrogens. How many? 3. One OH and 3 hydrogens. Okay. How do you know to add an OH onto a compound? You know, a couple good ways. All right, hang on, I'm gonna make a blank page so that we can, so I can write. There ain't enough room on that thing. Okay, so if we go backwards one step, how could you make that? Could you go back one step? What do you think? What would you want here? Here is your clue. Okay, so what do I want here? What kind of compound? Doesn't matter about that yet. What kind of compound can we make an alcohol from? Can we make an alcohol from a triple bond? No. What do you get? Ketones and aldehydes. Okay, so that ain't gonna fly. So what do we gotta do? We gotta have what kind of compound to make an alcohol? An alkene. Very good. So we're gonna have a alkene like that. Okay, what reagents do we need to make that alcohol? What? Lindlar? To go from here to there?
Oh, no, I thought you were asking.
No. We're just doing one step. But we're going backwards. So what are we gonna use to go from there to there? Water. Okay. So what would happen if I added water to this? It would get wet. Remember?
Oh, you need a
You need a catalyst. What kind of catalyst? H plus. What would happen if I added water and H plus to this? What kind of addition is that? It's Markovnikov. So who's going to get the H? Okay. And then is that going to get the OH? No, it gets worse. It rearranges. Okay. So that ain't going to fly. All right. So you see that? All right. So how can we fix this? How can we fix that? What can we add? Bless you. We're sneezing in the back. How do we want to add the water? What? Anti-Markovnikov. Okay, that's 2 steps. I'll give you that much. What's step 1? It's boron. There's numerous boron compounds you could use. BH3 is the simplest one. Okay, then what do you add? Yeah, hang on, I'm writing H2O2, NaOH, and water. Very good. Okay, this adds the water and timer calm together, and there's no reason. Okay, now I want to go back another step. I'm going to make from here to here. Can I do it in one fell swoop like that? Sure. What's the difference between that compound and this compound? 2 hydrogens, right? Okay, so how are we going to put them on? Yeah, you could use H2 and Lindlar. You could also do the dissolving metal reduction. It doesn't matter because there's no cis. Okay, so you're getting into the swing of it a little bit? No, it's going to take practice. Okay, we're also going to cleave our alkynes. Okay, just like we did the double bonds. Remember when we did this with the double bonds? We chopped them in half. We're going to chop the alkynes in half. Okay, notice that this uses KOH. When you want to make the diketone compound, it's neutral. Remember that? This is basic. Okay, and that's a 1E and a 2E, and the 2E is acidification because you are going to make these carboxylate salts. Okay, these carboxylate salts are salts and negatively charged because it's in base. So as soon as one would form, it would be deprotonated. So in order to get them protonated, you have to go through the step of adding HCl and H2O. So have you done a reaction yet where you have to acidify it to like a pH of 2? Have you done that yet? You may do that yet this semester. Okay, so this will have to be at a pH of about 2. Okay, and you just use pH paper to test that because you got to make sure that these guys get protonated. Okay, you can also do it with ozone. Okay, remember what ozone was? O3 followed by H2O. And you get the same thing, carboxylic acid. Okay, you always get 2 carboxylic acids. So if I give you 2 carboxylic acids and I say what alkyne did they come from, there's these carbons here. Oh, these carbons here are from here. Okay, it's like you literally cut it in half. Okay, they do some of this stuff to figure out large structures. So have you heard of a pheromone? Has anybody heard of those? They're typically compounds that are a lot of straight chains, and the ant one is real popular to synthesize in lab and stuff. And they have double and triple bonds in them. Well, when we do spectroscopy, in order to figure out where those double bonds are and stuff can be a little tricky. So one of the things they would do to study them when they were first figuring out the structures is they would cut them and figure out what each of the little pieces looked like and then go backwards and put them back together. So this actually gets done, okay, like for real reason, okay? Yeah, I know. All right, so look at this one. So here's our triple bond. We got ozone and water. And it's a 1E and a 2E. 1E and a 2E. Okay. All right, so what are we going to do? What is this going to do to this compound? It's going to cut it. New sound. That's because of triple bond sound. All those bonds. Great. All right, so what do you got? Well, from the left side, we get CH3, CO2H. Right? What do we get from the right side? CO2H, CH2, CH3. Okay. So you get CH3, CH2, CO2H. You could write it like this if you wanted, if that makes you feel better. Okay, how about this one down here? Let's bust this little guy up. Okay, so what do you get from the left side? You're going to have how many carbons in it? 5. And the 5th carbon is going to be the carboxylic acid. Okay. I'm trying to draw them the different ways so you get a little more used to it, because we haven't really done a lot with them yet. What do you think you get from the right side? Well, this carbon, yeah, does anybody know what that's called? Have you heard of formic acid? Where's formic acid found? Yeah, in ant bites. That's what stings when you get an ant bite. And when you get a whole lot of ant bites, it really stings, right? Have you ever stood on an ant thing and then all of a sudden they crawled up your leg and you got bit everywhere? Most kids have done that. It only took once. Okay, now how about this one? This one is the other set of reagents. The KMNO4 in base, followed by H plus and H2O. Okay, so what do we get? What are we going to get? We're going to get, wow, pen is not working well. Okay, and then from here we get the formic acid. Well, guess what happens in permanganate? You get carbon dioxide, and guess what that does? You can get rid of it really easy. So you can actually use that to make some simple carboxylic acid. Okay, there's one other way that you can make alkynes besides starting with acetylene. We're really fond of starting with acetylene. It just is so fun. Okay, but you can start with a dihalide. So that means that we have 2 halogens. They can either be on the same carbon or carbons next to each other. Okay, next to each other is vicinal, same is geminal. I don't know, is Gemini the twins or something? Yeah, I guess that may word all that. Okay, now you're going to need a strong base like sodamide or KOH at elevated. What will happen is you're going to lose HX 2 times. Okay, so do you remember last semester eliminating HX and making a double bond? We're just going to do it 2 times. So the first thing that happens, let's see, I'll use the ones that I did. All right, so here's NH2 minus. Okay, and we're going to get, this is going to grab this proton. Where do these electrons go? Down there to make the double bond, and then X minus leaves. Basically, you're doing the same thing 2 times. Okay, you have to have a pretty strong base. NaNH2 is the one that gets used the most because it is very easy, well, to work with because of the ammonia, but also because this step right here is the hard step. It's the second one to pull off. And you have to have a base that's strong enough to do it. And so you're doing the same thing again. We're pulling off that proton. These electrons are going there, and that goes bye-bye. Bye-bye-bye. Okay. All right, this is going to do the same thing, only let's see, which one did I pick on this one? I'm trying to make it match my little pictures is all. Okay, I'm going to take this hydrogen, that proton. These electrons go down here to make the double bond, and X minus leaves. So we get this. That looks familiar? Same as that one. Then the next one happens. So the halogens need to be on adjacent carbons or carbons that are, or on the same carbon. So it needs to be geminal or bisinal. I'm sure we have examples. If we don't, I'll make some up. I'm sure we do. Okay, here we go. Now look at this one. They use KOH, and you see in parentheses it says to use. It's like at a really high temperature. It's weird stuff I've never used. Okay, so what am I going to make? I'm going to make a triple bond, but where? Okay, you got 5 carbons to pick from. The carbons with the bromines on them. Okay. All right, what do you think about this next one? NaNH2, it's a little more normal, and 150 degrees. What do you get from that one? So you would get 1, 2, 3. Make sure I have the right carbons. Okay, you see that compound there? What do you know about this compound in the presence of NaNH2? What does it do? Doesn't it do a little acid-base reaction there? Haven't we made a bunch of carbon-based nucleophiles? So what will happen is as soon as that forms, an equivalent of base is going to pull off that proton. And so what will happen, let me get it so it looks decent. You can't tell the molecule, don't do that, don't do that, okay? It won't listen, okay? Trust me, I've tried. Okay, so this will pull off this proton, and you will end up getting this, okay? So what ends up happening is you end up using 3 equivalents of base because one equivalent pulls off the first HCl. The second equivalent pulls off the second HCl, and the third equivalent does this. You can't say, well, I'm just going to put in 2 equivalents and be really sneaky, okay? Because what will happen is this reaction is faster than those other 2, okay? And then you'll have a mess of everything. So what you have to do is go all the way, deprotonate it, and then at the end, you do an extra step where you add water. This only is an issue when you're making terminal alkynes, okay? Only an issue when you're making terminal alkynes. So you'll notice that in the homework and online and problems and all that. Okay, so that's an extra step. So sometimes they'll write it as a 1E and a 2E. Okay, and just put 1 NaNH2 and then 2, they'll put H2O. That's because you're making a terminal alkyne. If you're not making a terminal alkyne like one up high, like this, you wouldn't have to do the waters. Okay. All right, so how would you make that? We have a minute. We have enough time to make it. Okay, you can start with acetylene and any necessary reagents. I want you to tell me where are the 2 carbons of acetylene in that compound? Where do you think they are? Because that really helps you to figure it out. Okay, where are they? Yeah. Okay, so you can figure out what you need to add. So if we start with this, what are we going to do? NaNH2. Okay, what that is that going to get us? All right, then what are we going to do? Ethyl bromide. I'm liking it. So at this point, we have this. What's the difference between that and that? Yeah, what else? All of this, right? Ooh. Any brilliant ideas? Anybody remember anything that we talked about? Do you remember that if you do this, you're going to get NAs. You're going to get the other side. And you can add to that a compound with a carbonyl. Okay, so here's your nucleophilic carbon. It's going to go to the carbon of the carbonyl and out to the O. Okay, and then you would protonate it. Okay, make a sense? Great, so work on those. Okay, this is the end of chapter 9. So on Monday, we're going to start chapter 10, but I won't put it on the test. Okay, so 8 and 9 will be on this test. Okay, do you still have the old test from last semester? Because some of this stuff is in those other tests. We're kind of mixed up. That happens.
Are they all
Okay.
not online?
Do you want me, I put only organic 2 tests, but I can put the old test 4s from the other years up there too. Okay, I can do that. I'll add that to that today. Okay? All right, y'all have a good weekend. Work on your stuff. You have homework due Monday, don't you? We have a test on Wednesday. So Wednesday morning we'll review. Okay, and then Wednesday afternoon we'll do the test downstairs.
Yeah, I'll see you. Sorry. Oh, I should have everything. Oh, I see.